Stories are nice, but if we want to know what's really going on, we got to go out and measure it. If we're going to measure things, what are we going to do? Remember, if I point to one star and maybe there's a planet, and I go, there's a star, there's a planet. Notice the angle, right? There's moon, there's Mars, whatever. And then another night, maybe it's Jupiter's over there. So angles are important, and we're going to divide up Earth, and we're going to use some angles. Now, it may have been a long time since you've done angles, or maybe not. If not, then this is a big review. But let's take a moment and talk about how we slice a pizza. So we go out for a study break, and well, we can just order it in. So pizza comes, and we're going to cut it up, right? So we got a whole pizza. How much is a whole pizza? You may know to turn around once. If I go like this, if I jump and I turn around once, this way, or I could do a circle that way. We call it a 360, right? Oftentimes. And so, make sure you're good with that. All right, 360. So what does that mean? We say once around, we call a 360. All the way around. Okay, whole pizza, whole circle. Next, our friend comes over. Oh man, all right, fine. I'll share some with you. So if that's a 360, then half around, 1/2 around, we'd have to call that, this one goes all the way around, that, remember this, is a 180. And I put a little circle up here, 180 in that circle. Let's do that a little clearer. 360 there. And you probably know that that means degrees. What is a degree? It's fine. If you know this, just let it go. We're gonna build on it, so you're still gonna learn something. Now, we've cut it in half for our friend. And then we get that couple that come over, and they're gonna study too with us, and that's cool. So we're about to cut it. Right? And if we cut that, we'd have a 1/4 around, which means we divide that into 2, and that means 90 degrees. And what we're talking about is how big that wedge is, how big the slice is, right? But before we cut it, luckily we didn't cut it yet, that other couple comes over, you know them. And so we say, okay, fine, we're cutting it because I'm hungry. We go like this. So 1, 2, so I've cut 180 into 3. So if I divide that by 3, I get 60. Or the whole thing I've cut into 6, and again, divide that by 6. 360 divided by 6 is 60. So 1/6 around, and we're going to talk about that, is 60 degrees. Interesting, 60 degrees. So let's see, where did this system come from? Well, we're talking about, but that's kind of funny numbers, right? Why don't we just say whole once around, or half, or a 1/4, or a 6? Why is this stuff here, 60s? Well, it's kind of crazy, but it's also kind of brilliant. I mean, if you don't have calculators, I have one around here somewhere, but I lost it, and I'm back in Mesopotamia, right? Babylon, Iraq, no bit of history, thousands of years ago, right? People didn't have calculators, but they were smart, and they were figuring things out. And if you want to share stuff, if you want to divide stuff evenly, it's kind of a drag to divide it into fractions. You can divide it up into easy parts. How do you do that? You use 60 as your base. So for example, 60 is equal to 6, let's do it this way. 1 times 60, so that's all of it. 60 is equal to 2 times 30. Think of a clock. We're going to talk about that. 60 minutes. What's half of a clock? Well, 60 minutes has 2 30 minutes, right? It's also got 3 20 minutes in it. It's got 4 15 minutes in it, doesn't it? You might not think of it this way. it's got 5 12-minutes, or if you want, 12 5-minutes, and of course, 6 10-minutes in the clock. So it divides up really nice, a great number for kind of separating things, dividing things, right? So base 60 makes sense, and that's where our clock, 60 minutes in an hour, 60 seconds in a minute. Where really did it come from? Where did that start? Talk about arcs here, because back then in Babylon, we're talking 2,000, 3,000, 4,000, long time ago, years ago, antiquity, where they didn't have clocks or watches. Okay? So they did, though, know about angles. They did measure things. So why 60? Because it divides up simply. That's it. You ever think about that? Why? Who made 60? Okay, 60 minutes in an hour? Why did you do 60? Why not 100? Okay. So you got your friends over, you're dividing it up, you're sharing, and then everybody in class comes over. So then you slice it as thin as you can, and everybody's got hors d'oeuvres, which is kind of a drag, right? And you got, how many hors d'oeuvres do you have? Well, how about 360 of them? That's a lot of friends. So, and we're going to talk about how big is one of these slices of pizza. 360 hors d'oeuvres or slices of pizza. So we're going to take a look at that. Before we take a look at that, 360 degrees. So that is the symbol for degrees, which is a circle, which is kind of cool. People just made it up, right? 360 degrees. What is a degree? We will see that momentarily, but I've got a little drill for you, because this is going to be how it applies to astronomy. So let's talk about this. We're going to be mapping out what we see. So I ask you, how much are these things? Half a pizza, 180 little teeny slices, 180 degrees. It says right there, 180. You can see that. So what is the angle if I face north and I go horizontally level? So let's just make that. There's north. And I go around to south. Well, if that's north, where's south? Right? What's that angle from there to there? Half a pizza, isn't it? North to south. Pause and do these, see if you can get them before me, because when you hear it, you don't process it in our brain as much. So the answer there, north horizontal to south is 180 degrees, half a circle. What about north to east? Where would that be? Oh, how do I do that? Oh yeah, remember? Wine. But really, it's not a straight line. It goes north and I rotate around until I get to east, don't I? And what's that angle? What's that angle? Horizontally, north horizontally to east is not a full circle. It's a quarter of a circle, isn't it? South would be half a circle. East would be a quarter of a circle. 90 degrees. What if we go up? What if we go up? So now I'm going to go like this and go, okay, what if I do eye level? Not down there, not up there, eye level. This is going to be actually useful. Eye level. And I want to go horizontal, eye level, up to straight above my head. What's this angle? Yeah, I got an idea. Let's use that eye level as a reference and then do this. What do you see? Straight above my head is there. What's that angle? How much of a circle is that? A quarter of a circle. 90 degrees. That's what 90 degrees is. Upright. Upright. Upright relative to the horizontal. Up. Right angles, we call it. So what would that be? Oh, that would be 90 degrees up. this would be 90 degrees around. We're going to use that in the next section. 90 degrees. What if I do north at eye level, straight up and over, and down to south at eye level? North, up, 90 degrees, down another 90 degrees. What is that? If that's north, I go up and down to south. What's that angle? 180. Eye level to straight above my head, called the zenith, is 90. North, up, and down would be 180. And so we're going to talk about angles a bit. Not too much. We're not doing calculations so much in this class. But we want to have an awareness how people got beyond the stories and how they did that as they measured things carefully. And they tried to find out little more subtle things so that we could argue about things, but let's measure it and see who's right, okay? So that's those angles there. And now I want to get back over here and talk about, well, how big is one of those hors d'oeuvres? 1 degree. How big is 1 degree? Well, you got to slice that circle 360 times, nice and even, so that you're fair. I've drawn a straight line there. Let's get rid of all this. And let's use our protractor, our hors d'oeuvre maker. And we're going to put it right on there. Okay? And I'm going to show you how big 1 degree is. And then I'm going to show you something cool. And then I'm going to show you how this applies to astronomy, as well as so many other things: construction, building cathedrals, building pyramids, building cool stuff, whatever, you know. So how big is 1 degree? Well, let me check that out. I need something. Maybe let's do a black pen. It's darker. Here we go. I'm going to go here. I'm going to take one little angle, one little sliver. Each of those is going to make a wedge that we call 1 degree. Why? Because people decided to divide up the pizza. It's all about pizza. So you go here. Watch what happens. Now this isn't going to be exact. It's tiny. Oh, that's a wedge. Good luck. I'm not going to make it perfect. But let's just say that is an hors d'oeuvre. That is not a meal. All right, cool. Let's go out even farther. Keep the angle, same angle. Notice that the wedge is the same amount around. The same amount around, the same wedge. But look at what's happening to the end of that. What if I keep going? If I keep going out. Still 1 degree. This is all from there to there, 1 degree. Now I'm going to show you something. We're going to get some interesting little bit here. Couple things. Not making it perfect, but that's not bad. 1 degree. That wedge is a 1 degree wedge. And it would take me 360 to go around. That's probably bigger than a degree, but it's hard with the pen to draw that just right. Okay? So 1 degree. Yes. Mm-hmm. Oh, okay. Yes. Got that. Got some cool stuff in here to share with you. How big is 1 degree? All right, there it is. Notice that the ends get farther and farther away. In fact, going to see something interesting. I'm going to tell it to you now, and then you'll see how to measure it. But moon, if you go from one side of moon to the other, is only a half a degree wide if you were to point to one side then the other. And so is sun. So is sun. See, if I put moon out some distance, it's really half a degree, so I'd have to make it half. One half a degree wide to our eye. It's surprising, I know, it's surprising. Right, if I did this, let's see, what was I doing here? Oh yeah. If I put that out there, did I do that about right? About a meter? No, let's put it out a little bit more. Let's go here. All right, there's moon. Turns out that sun is about 400 times wider, but it's 400 times farther away. And so sun would have to be out like 4 football fields, 400 meters, 4 football fields. And you can imagine how far apart those ends start getting for 1 degree. And that would be how big sun is. But it would look the same. Because we're going to put our eyeball here. And look. And so they look the same size because what we see is the angle. All right. So when things are far apart, they could be huge. But you know that as things get farther away, if I walk closer, if you point to one side and the other, it looks like it's a bigger wedge, and as I go farther away, it's going to be a smaller and smaller wedge. Right? You can do that with my hand. Now it's going to be a bigger and bigger wedge. Now it's a smaller and smaller wedge. Right? It looks, whoa, my hand's growing. Ah, it's growing. Oh, it's shrinking. Oh, it hurts. It's shrinking. Right? It's crazy. Video is crazy too. Makes things look really big, like close like that. So 1 degree is a small angle, but things even to objects, for instance, I could say an object, let's get rid of moon. I have an object here, say a star, and another object here. They would be 1 degree apart. But you remember we can't tell distance away, but we could tell angular separation, so I'd see it, but maybe, in fact, this one's over here. Still, when I look at a line, they would be 1 degree apart. Visually, I'd point to one then the other. I can't tell this distance because we're talking light years for stars, AUs for planets, much closer planets. And so things get farther out. So you could imagine that things could look really close to each other and yet actually be far apart. So let me show you this one more little thing about that I think is cool. And then I'm going to tell you how to deal with small angles. You see, what is this? Let's see if it holds together. I just need to make this video. This is a certain distance, 1/2 meter, 1 meter, 1.5, 2. Certain distance, twice as far, 3 times, 4 times as far. And if I make the same size wedge, the same size slice, oh yeah, when it's for the same slice of pizza, the farther away you are from the eye, that distance, the farther away the ends of the lines are. In fact, if you get twice as far away, the ends, so if that's something that fits in there, it's twice as wide. 3 times as wide, 4 times as wide for the same wedge. So don't worry too much about this. But things are so far away, and again, as things move farther away, they look smaller and smaller wedge from one side to the other, that in astronomy we often need tiny angles. And I just want to introduce you to this a little bit. And how do we deal with tiny angles? Well, tiny angles, we're almost done. We're going to use a tool besides protractor. Tiny angles. We're going to take 1 degree and we're going to slice it. Now, let's remind ourselves about time. Time. 1/60th of an hour equals 1 minute. 1/60th of a minute equals 1 second. We'll talk about where those words come from just briefly. I'm not going to do the whole history, but it turns out when things are so far away, they can be very close. And if they're so close together, they look like they're connected. You can imagine 2 headlights as they get farther and farther, or taillights, farther and farther away. They look closer and closer together until they blur together. This is very important for chapter 10 and for the idea of resolution. Even though there's 2 headlights, their light blurs together because they're getting farther and farther away. Okay, so you need a telescope to magnify that angle or to spread them out so you can see that they're different. But we can do small angles. So here I've got 1 degree. I'm going to slice it. How many times? How many times should I slice it? What's nice, easy? Oh, you take 1 degree, sliced 60 times. Then we have one of those little slices is 1/60th of a degree. A full, degree, that's the symbol, right? 1/60th of a degree. And how much is that? 1 arc minute. We write that 1 arc min short. We can do better than that. We can do 1 slice it up. So that's how we really write it, because who wants to write that? Arc, an angle, a wedge. Minute, literally minute, from the word for small, minutia, tiny. That would be a tiny slice. But things so far away start getting so small, right? So the same distance away, it's going to get smaller and smaller, appear smaller and smaller. I'm going to show you that in a second too. Okay. So that's one slice. And even really find things very, very far away. Right? Millions of light years for close galaxies, billions of light years for distant galaxies. And so we're going to take that, are you kidding me? And we're going to take 1 degree sliced 60 times. Oops, sorry. 1 arc minute, or minute, a minute arc. That's the root of it. And you're going to take one of these teeny hors d'oeuvres, and how many times are you going to slice it? 60 times. And what's that called? 1 arc second. Why? Because you're slicing it 60 times a second time, literally. That's the root of the word minute, or minute, and second. You're going to do it a second time. 1 arc sec, easier, or a double slice. And that is a pretty pathetic hors d'oeuvre of pizza. So we talk about tiny, tiny angles in astronomy in arc minutes and arc seconds. A degree is a pretty small hors d'oeuvre too, right? But then 1/60th of a degree is an arc minute, and 1/60th of an arc minute is an arc second. These are just terms. You won't do too much with it, but you should be a little bit familiar with them. So I'm gonna show you that. So measuring angles came first. If you measure them big enough, you could do this. And people were clever, man. But they didn't have clocks. And so then you apply it to time, particularly ones that go round a circle, don't you? Okay. Now, check this out. Let's do this guy. If I put it here, notice the angle. Watch what happens. I look at this and it looks big, doesn't it? It looks bigger and bigger. It looks smaller and smaller. Look at it's the same size. What we see is the angle. If it's a person, we know that they aren't shrinking, they're just getting farther away. As you get farther and farther away, that angle's going to go right, teeny tiny. For the size of things or for the separation of things, we use angles. So we use angles. And that's a little introduction to angles. Now you might say, hey, I don't have one of those cool things hanging off my belt like you do, because I'm just not that cool. But protractor in your pocket, oh yeah, that looks good. A bunch of pens, sporting. So what you do have this. If you got this, not everyone does, a fist. And so what we often do is to go, about how far away is Mars from Moon? Or how far away, just recently, Saturn and Jupiter? How far away are they? I say 10 degrees. You go, what does that mean? Last thing on angles to prep you for this. You ready? This is going to be good. We use our fist, look. Oh, my fist is really big. Oh, my fist is shrinking, it hurts. Ah, it's shrinking. For you, it's getting bigger. Look, my fist is small. Ah, it's growing. Ah, it's shrinking. It's just what you're seeing is that angle. Look at the exercises in the book. Now in the text, I go a little crazy and I say it with a little trigonometry and stuff. In my class, you don't need that. If you're interested, you can get a taste of what happens when you add a little bit of math to this. Which when we do astronomy and stuff, we add math and physics and computer stuff and all kinds of stuff to figure out these crazy puzzles. So, there it is. Ha-ha. Clean this up. I want to show you something. So, don't obsess about this, but I think it's kind of cool to see that 60 divides up easily to share things in nice round numbers. It's kind of cool that we divide things a minute amount and then a second time, and we get that. How big is 1 degree? Now, the last one, the protractor on your body, your hand, not close, it's got to be at arm's length. I'll show you. You might question that. That's okay. Questioning is good, but check it out. Here's my eye. There's my eye. Make sure that you're okay with that. Yes, alrighty. Cool. Let's do that. All right. Now I'm going to look out here on this reference line. Yeah, I'm not going to be too picky, but how about? Eye level, I went up a little bit, I don't want to go up, let's just keep it going down. Horizontal or eye level, the horizon, soon to be. There's my eye level. But it doesn't have to be eye level, it could be anything from here to there, making a wedge. Just, we're not going to go too far, don't worry about it. But we're going to do it. And now what I'm going to do is this. Let's do that. Okay. Take this. And I'm going to check to make sure. Put my hand at arm's length. We're good. Still rolling. good thing. Here it is. Boom, my fist. So I can see one thing past my pinky, and I can see another thing past my thumb. It doesn't matter how far away it is, it still makes the same wedge. That's how wide my fist is at my arm's length. At my arm's length. How big is the wedge? How big is the pizza slice? How big is that? Well, let's try it out. Now it's pretty loose, so don't have to worry too much, but it does kind of end up pretty nicely. What's the angle? I got a protractor. So once I use the protractor and check it, I won't need it after that. Here it is. I wonder if you can see it. Zooming in, put the 0 right on that line, okay, and put it right there at that point. And it is 10 degrees. Now, make sure I gotta start that at the beginning of the line. And yeah, that's gotta go right there at the beginning where the line went. Put that down. Pretty much 10 degrees. And sometimes when I draw it carefully, it's exactly 10 degrees. So that is 10 degrees. And that is still 10 degrees. That's how big the wedge is. And this is my fist. Fist width, pinky to thumb, anything from one side to the other, anything from one side to the other, from my eye, at arm's length, and it doesn't matter if I lift it, tilt it, whatever, that wedge is 10 degrees. About. Okay? So fist width at arm's length. What about my thumb? 5 degrees from the base to the tip. Be like a painter, right? At arm's length, 5 degrees. Thumb length at arm's length. I can't do this because it looks bigger, so it's got to go like that. What about pinky? 1, 2, 3. My finger size varies a lot, so I got to go this way if I really want to get it. 1, 2, 3, 4, 5. It's about. About. Here we go. One degree is the width of pinky tip from one side to the other, that little wedge, pinky tip at arm's length. So you can do it. Now do this. At arm's length, look from one side to the other, do that. See, is moon 2 of these pinkies? That would be 2 degrees. One thumb across is moon a thumb, that would be 5 degrees. Half a pinky would be half a degree. Try it with a full moon. You'll be surprised. And then what about on the horizon where it looks really big? It's an optical illusion. Measure it. You can measure it. You can do this, right? And so there's your tool. And you might say, well, but I have longer arms, or I have longer arms or shorter arms. Maybe, my arms are a little bit too long for my size, but interestingly, if you have a shorter arm, you tend to have a smaller fist. And if you have a longer arm, you have a bigger fist. It works pretty well, good enough, unless you want to carry one of these around, right? But that's how we do it. And then we'll talk about someone that measured some angles between things and broke things wide open. So that's angles. Sorry it took so long, but a little bit of a preview. You got the notes and you got the book. So ciao for now. We'll get to your sky.